Hello, good morning, everybody, and welcome to this office hour session on cloud native services for Oracle. So we are introducing this new channel on the AskTOM platform that is well known for all the database environment, the database development contents. And we are trying now to extend also to Oracle Cloud Native Services. And today we are hosting here Hassan Ajan, and he will introduce us to the content of the Oracle Cloud Native Services and why choose in general Cloud Native Services, and maybe Oracle are the better one in this moment. So just a quick reminder, you are now subscribed into this channel. You will get information on the next session that we are going to produce. And we have also a session, a conference, Developer Live, as you can see here. The next one will be the 17th of September on Java. I invite you to register, but before to register, to check the agenda and understand how relevant are the content that we are going to present during the day. So now the ball to Hassan.
Perfect. Thank you so much, Ithori. Let's kick this off. Let me just share my screen with you all, and I think we're good to go. Almost there. Perfect. Ithori, let me know if everything is okay and you can see my screen.
Yes.
So thanks, Ithori. My name is Hassan Ajan, and I work in Oracle. And I've been a system admin for over 15 years. And the last few years at Oracle, I've been focusing on cloud native and Kubernetes and basically anything to do with infrastructure, which has been evolving a little bit. And it's been a very, you can say, very boring area for many years because not much has happened. But in the recent areas, there's a lot of things that have been changing, and it's been very, very exciting. And that's what we're gonna discuss a little bit today. So we're not gonna get into the nitty-gritty technical details today because we have another session where we'll discuss how to do things and all the technical details. Today will be more about why choose cloud native, but of course we will discuss some technical aspects. So let's jump right into it. I want to start with just imagine if you could build basically anything in your infrastructure, basically any stack, any sort of setup with a single command. So you run a single command and everything is just launched. Anything you need, whether be it load balancers, be it network, be it your application, the configurations, the different systems talking to each other, everything launched with a single command. How would that be? Imagine if everything you have in a specific stack could be controlled from a single file. So you have a single file where you have, let's say, in the example that I have here on the right side, this file has MySQL in there, it has Redis, it has Puma, which is like a Rails application server. There's a Rails application, a load balancer, etc., etc. Imagine if one single file for my full stack, I can basically control the versions, I can control the number of replicas I should have, I can control whether this is a testing environment, a production environment, and what should happen accordingly. Basically, any configuration parameter, even on my application, could be controlled from that single file. What would that mean, and how would that, to you? And if any of you are doing this today or have something similar, please let me know in the chat. I'd love to know if you have something, if you're doing some similar, way of managing your environments. What would it mean if we have a system where it's almost like autonomous? It can monitor your services, you've told it what it should look like, and it can monitor services. If anything crashes, it can simply restart the services. It'll check that your, the number of amount of services that you wanted to have are running. It can, make sure that if a service doesn't have the resources it needs on a given machine, it'll move that service somewhere else where it will have those those resources available. How would that, make your life easier? How would that, remove, uh, responsibilities from you, or at least less worries when a system can be, autonomous and be so automated? Now, of course, this is not just dreaming. This is this is all possible out there, and there's various ways of, you can say, achieving it, right? And you probably all know this. The thing is, though, is that some solutions out there require a lot of efforts to achieve this, while others, you can say, don't require as many efforts, but might not be suitable for any sort of application. So let's go through them. These are just some of the solutions available out there. So serverless is like one option out there. The problem with, or the challenge with serverless, it's typically it's based on running everything as a function or as a tiny little bit of an application. I'm not going to get into too much into it. Like I said, this is more the advantages and benefits we want to discuss in this session. But the idea with serverless is that you kind of take your applications and look at the tiny part or task they're doing, and then you make a function out of that, and then it can run in this like fully managed service, and it's like spun up on demand. Whenever someone calls that function is like ready to run, does the request, and goes away. So obviously, when you have bigger applications running in things like, let's say, WebLogic or just a Tomcat or any sort of like application server, it won't, it won't be suitable in the same way. It's slightly different. Then you have PaaS services. So Oracle is obviously not the only one who has PaaS services. There are a lot of vendors who've been around for many years with PaaS services. And I've put / autonomous services. Autonomous services are still, you can say, still new. With Oracle, it's at the moment mainly things like the database, the Oracle database, where we have a fully autonomous service. But when it comes for things like hosting your application, running your application, there've been different approaches and different you can say solutions to how to run an application where you don't have to worry. As a developer, as a system admin, I can just put my solution there and it will, let's say, auto scale, or it will run automatically, and I don't have to worry about managing it. The challenges that I've run into in the past when using PaaS services for hosting applications is that it's always a question of control and flexibility versus this manageability. Like, you can either give away everything, but you're also losing a little bit of control. You don't necessarily have root access, or you won't be able to customize things as you want. You're limited to perhaps the services that are offered as a PaaS service. You can't bring any sort of application server. So typically with PaaS services, there's certain limitations, but that's been a way to, it's been around for a while, and a way to kind of like put your application there and have it run fully managed. And of course, managed hosting, you can always give it to someone else and say, this is your problem, please take care of this. And then there's building your own automation. And I think this is where most people have been, or a lot of companies out there, and a lot of what we've seen businesses have been focusing on building their own automation. They've been using a combination of tools like Chef or Puppet to automate the deployment of the applications, automate the provisioning of the infrastructure, be it on premise or in the cloud, using things like, for example, Terraform to spin up the application, the infrastructure, spin up the VMs, the storage, the network. But then you still have the second part of the task, which is deploying the application and making sure it runs. Now, that part was typically done with Chef Ansible or Puppet. And to do that is the code base for that automation. It almost becomes like a new application that you need to manage. And I've been doing that in a few places. And what I noticed was that after a while, you have all these components that all these services, let's say, you have a WebLogic application server, you might have a MySQL database, a Mongo database, and you build automation, like let's say in Puppet, you'll have these modules that are open source, they won't work together. You end up having to customize them and then having to make them work together. And then all of a sudden you're managing and you're having to to focus and take care of all these different modules, which just takes care of the automation. So it's almost like creating a new application project, and that's really not what wasn't intended from the beginning. I'm not saying they're bad tools; they're fantastic. Puppet is fantastic. Chef is fantastic, but it does require almost like a team to manage those things. The next thing is cloud native. That's like what you can say has appeared in recent years, and is the new thing to the new way to handle things. And when we talk cloud native, I think there's a lot of different ways of explaining what that is, and people have different explanations, and we'll get into that. But from a solution perspective, we're often talking about Kubernetes as a core component, and that's kind of the topic of today, is how can we use Kubernetes? What sort of benefits will give us when we use Kubernetes to do this? And what I just showed you a second ago, that was all done using Kubernetes and some open source tool to manage that. It has this, it allows us to this sort of automation. And if there's any questions, please ask them in the chat. I'll just check the chat to see if there's any questions yet. Perfect, nothing yet. Fantastic. So what does cloud native mean? This is one of the explanations. It's basically all about changing the way you think about constructing critical business systems. Cloud native systems are designed to embrace rapid change, be large scale, and resilience. So it's basically like the same, you can say, goals that anyone would have when building infrastructure, right? Or maybe not everyone would have those sort of goals, but typically, if you follow best practices, that's the sort of thing you want to do. And that's why I mentioned the other solutions like Puppet, Chef, Ansible. Often this is what people want to achieve when they work with these tools and what they automate infrastructure. Now, from just what's happening on the market, you can see here that from an adoption perspective, a lot of companies have already adapted cloud native, and so containers, Kubernetes, and the systems and the other solutions in the ecosystem, and it's growing at an amazing speed. The adoption is really massive, and this is why you'll see that the tools out there, the documentation is fantastic. You'll see a lot of documentation out there that can help you get started. You'll see a lot of examples, a lot of discussions, and the way the tools of the ecosystem are developing is happening really fast. So it's I think it's something that you can say this is the direction we're going towards in the future. I would almost go so far and say that cloud native, containers, Kubernetes is almost like a replacement for things like virtualization. Virtualization, of course, will stay there because it has another objective, but I think running things on directly on VMs in a few years, I think that will be probably that'll be history. Coming back to the advantages, obviously, what happens is when you run these things in containers, one of the advantages that you get is that you don't need as many VMs, or at least operating systems. Because you're unifying your system, and I will get into the whole how a Kubernetes cluster works, but you're unifying your system so that you get a reduction in expenses, because You don't need as many licenses, you don't need as many servers, you'll be able to scale, etc. faster. The maintenance, the cost reduction in maintenance is, I think, one of the places where you can really, really save. Because there's so much automation, you will be spending way less time having to maintain your infrastructure. And of course, there's the whole developer productivity. It'll enable you to give your developers environments much faster, so they can develop quicker. You can go to market quicker. You're able to bring changes to customers quicker. So again, automation is obviously the key thing here, and it has various benefits. Now, so let's go back a little bit and say, what are we really talking about? What are these containers, right? So most of you probably know what they are, but if there's anyone out there who doesn't know it, let's just quickly highlight the differences. So on the left side, we have this bare metal machine, and often what people used to do is they'll just run an application or two, or maybe more, on a physical machine. So that's why you see the physical machine and just like these things installed. The disadvantages, of course, obviously you get great performance, which is an advantage because it's running directly on the physical machine. The disadvantage is that if you start running too many things, separating between different applications, dependencies, libraries, and all of that, you'll have to find ways to isolate every application, etc., so they don't conflict. And of course, you have the whole idea about when something goes down, the dependency on the physical disks and all of that. So there's a certain single point of failures, etc. Then virtualization came along many years ago, and often it allowed us to split things up and run everything isolated. Now, what happens is every VM still has an operating system. You still have to reserve typically memory and disk before the creation of the VM. So when you create it, you have some certain resources that are set aside for this virtual machine. And of course, you have the whole thing about IP addresses and networking, and often the applications you need to configure, each VM and tell it, where's the other VMs that you need to connect to, what are the IPs and all of that. And that's the sort of thing that people were automating with things like Puppet, Ansible, Chef to automate this sort of thing. And the provisioning was automated with things like Terraform. On the right side, we have a Kubernetes cluster. The way it works is the cluster itself is, you can spin it up. There's something called a master control plane, which is basically it has all the management components of a cluster. So like a scheduler, a service registry, where basically every service that starts is registered and it keeps track of its IP address, its port, what sort of type of service is running. And you have a scheduler, which is the component which kind of runs different bits and parts of each application or service, knows where it should run. Is there enough resources on this VM? Okay, let's put it there. Did it crash? Let's restart it. So the control plane has all these management components, which basically manages the services that are running. On the cluster itself, it's typical. It can be physical machines, or it can be VMs. So here in this example, I have 3 VMs. So those would be what I call worker nodes. So the cluster is basically a cluster with a few VMs or bare metal machines, and on those is typically some sort of a container runtime. You can use things like Docker, or you can also use alternatives. Often it comes with a Docker engine, meaning it can run Docker images, containers. And in this example here, I'm showing I have 2 applications in a database and on each. To build this sort of thing, normally that would require, again, a lot of automation and a lot of, you can say, planning. How do I distribute these? How do I make sure they communicate? How do I make sure that they know what the IPs are in different places so they can, connect to each other and talk? So all of that this is the sort of thing that's handled by Kubernetes. Again, like I said, today's session is not about the technical details. It's more just to give you an overview. There will be a more detailed session on the technicalities of on how all this stuff works. Let's just check the questions again. I think we might have. Nope, that's it. Sorry, fantastic.
You have a question, Hassan, in the
I do.
Q&A, know in the chat.
Oh yes. Okay. A lot of definitions of what is cloud native, and it's complicated. A lot of projects, a lot of components. According to what are the main components of cloud native deployment? So what are the main components of cloud native development? What is the bare minimum starting point? Okay, very good question. I think the starting point, the main starting point for cloud native is, I would say, is containers. So containerization and automation. Okay, and I'd say you can almost not talk about containerization without talking Kubernetes, because Kubernetes is almost the de facto standard for having a cluster where you can run these things, where it takes care of all the difficult tasks. So containers, Kubernetes, and automation. Can you run cloud native with VMs? I mean, yes, you can still, the components of scalability and resilience, you can automate yourself out of that as well. So yes, you could do that, but I think, yeah, but I think containers are an important part. So that's a little bit about the whole history of it. Now, what's our aim? What's the main benefit of when we start running things in containers? Like I said, infrastructure as code. You can run this with both VMs and containers. This example that I'm going to show you here is both applicable to VMs and containers. But the whole idea is that when I have an environment, I can recreate that environment at any given time in a few minutes with a few clicks, because that's what gives me the quality assurance, of my infrastructure. In the old days, if any of you have been around for many years, you remember that whenever you made a configuration, a change in the infrastructure on a server, you'll go and document it somewhere in a Word document, say, oh, we made this change, and you have this change log, and you write all the things that changed, so everyone knew what happened on the different servers. Now, the best way to know how something has changed is that your actual scripts, that you're not changing anything without changing the recipe itself. That everything that's created is created from a recipe and not the other way around. You don't go make the change and then document it. No, document it first and then apply the documentation. The idea of infrastructure as code, which is both applicable to Kubernetes, but also to things like Terraform when it comes to VMs and cloud resources. The idea is that with Terraform, you define the state of your infrastructure, you define the state of your cloud, for example. Say, I want these networks with these subnets, I want these VMs with so much memory, and I want these security rules and firewall rules. Now go execute that. That's your recipe, that's your documentation, and you can reapply that 1,000 times and it will create exactly the same time every time. That's the idea of infrastructure as code. And what it gives you is that it gives you the quality assurance. It gives you that you can that you can sleep safe and sound at night, because whenever someone clicks deploy or whenever someone creates a new environment, you'll have the exact same thing. And that means the application you deployed in the first environment will react and act exactly the same way on the second environment. There will be no surprises. In the Kubernetes world, it's called Helm charts. What you saw me use in the beginning, those were built on Helm charts. Helm is a little open source component, which again allows you to write recipes for Kubernetes. Allows you to define exactly what you want, but you can do much more with Helm charts and Kubernetes that you can with Terraform. I'll explain what that is. So, an example here. Persistence is one of the things that often was, discussed in the beginning of containers. Is like go into them out and create new ones, etc. Right? But there are multiple ways to handle persistence. As you see on the screen here, if you're running in cloud, if you run things like Kubernetes in cloud, what you get is you get the best of both worlds. You're able to use cloud resources, things like object storage, block storage, file storage, in combination with your containers. So you can basically spin up an application in a container and tell it, you know what, this application, this is a database, it should have persistence, so use the block storage. What would happen then is it would go and provision the block storage and attach it to the VM where that container is running. And you can even go so far and say, if this container crashes or restarts for some reason, make sure to attach the exact same block storage to it. So you get full persistency just like you would with any VM. That's the idea of persistence with containers. The other part, which is really interesting, is the autonomous database. Sorry, the other part which is really interesting is the service broker. I just got distracted here. The service broker allows you to provision any PaaS service without having to go and do it manually from the UI console. You can basically take and say, my application requires a load balancer. Then it will provision the load balancer resource. You can say, my application requires a database, which is running as a PaaS. What will happen is, in that same Helm chart, that same little description that I said before, when you run that, it will create your containers, it will create your application, and it will then go and provision your autonomous database, for example. Get the IP address, make sure to give that to the application so they know what to connect to. So it will automate both worlds, both the resources that are in the cloud, but also the components and the services that are within the resources within Kubernetes. So both things. And this is just an example here, like of what sort of services within the Oracle Cloud that are supported with a service broker. Things like the autonomous database, autonomous data warehouse, streaming, object storage. And again, today, the way for doing it often is, manually through the console, or they'll try to use, let's say, a combination of maybe Terraform and then some other deployment scripts. When you go, let's say, the cloud native way and use a tool like Helm, you'll only describe it in one place, everything. You won't go and have to provision multiple things different places. That simple script is the one thing that you need, and you can recreate it and it will create everything for you again. Another benefit that you have is that you can, often with a lot of, let's say, the PaaS services that we mentioned before, often those are only available in cloud. So it's only good for you if you can be on, use cloud. And also during test development, etc., for those who like to use their laptops, for those who are, for example, offline or want to just run things locally, it's difficult to take that PaaS service and run it on your laptop. With things like Kubernetes, you can easily spin that up on your laptop. So there's things called there's a thing called Minikube, for example, which is made simple and with minimal resources to be able to run on developer laptops. So that allows you to basically, during the development stage, to be able to test and run things exactly the same way as you would later on in production, very early on. It'll also allow you to run, let's say with Oracle, we have got something that's called Oracle Cloud Native Environment, which is Linux, which has support for Kubernetes and a lot of other open source tools. So that allows you to run Kubernetes on premise and run a hybrid model. And basically, you avoid vendor lock-in with this, because you can, what you developed, the recipes you created, your applications, your containers, can pretty much run on any Kubernetes. So you can take that and run it anywhere. Now, let's focus on, let's zoom in a little bit on OKE. OKE is basically the Oracle's version of the Kubernetes cluster. It's a managed Kubernetes cluster, which again gives you a few more benefits. So with Kubernetes, the difficult, or I'd say the challenge with it is it can be a bit of a beast to manage that part. So those who want to manage it, there are tools out there like Terraform and other tools that can provision that for you. But if you don't want to, let's say, provision Kubernetes and you don't want to manage it, there's the other option, which is a fully managed Kubernetes platform. So that allows you to basically spin up a Kubernetes cluster, which is fully managed. You don't have to worry about all the management components. All you need to focus on are the components, which is basically the worker node, which is where your workloads are running. So all you need to focus on is scaling it up or down. How many VMs do you want? How many worker nodes do you want in this cluster? That is free. So basically, you don't pay for those components. All you pay for is the VMs where you're running your workloads. The registry is a place where you can save your images. So your Docker images, whenever you create those, they need to be saved somewhere. So it's Docker compatible as well, and that's also the registry itself is also free, but you pay for the storage. So again, one of the benefits of running this in cloud, or at least Oracle Cloud, is that you get a fully managed Kubernetes cluster, and it's for free. You only pay for the VMs. Now, let's have a look at a use case where we take a monolithic application and turn it into a microservice. Now, if we imagine this was our standard application, it's an application server with some UI, and it has data access to, let's say, an Oracle database. What the steps you would take to, let's say, go cloud native? First of all, we would want this application to be able to run in a container. Now, some applications are suitable to take as they are and run in a container. Some applications might need some refactoring. It depends on how big it is. It depends on what application server you're using. It depends on a lot of things. Excuse me, I just need to. Now, in this example, we're creating, we're refactoring the app. So we have two services. One of them is accessing a relation data store. The other one is accessing a JSON data store. The way the things would work is that this application would typically be written in some code, and this would have probably be in a Git repository. So that code would need to be, you need to build some containers out of that. And what you would do is you would use something like a build server to take your code, make an image out of that code, take that image, put it in a registry. So the registry where you save your Docker images, and the CI/CD server could also take those images and deploy them. So this is basically where the automation happens. A lot of the automation for deploying the code, moving it around, taking it from what it is, will happen in the build server itself. And that will deploy it to something like OKE, for example. If you have, let's say, running, or you have a dependency on an Oracle database, like the Autonomous database, you could have in your description here of your Helm chart, you would have a description of the dependency like Autonomous database, and it will provision that as well. So this is the sort of process that would happen. So one thing to note is that you don't necessarily have to change the application. The refactoring is not a necessary thing that you have to do. The main thing that you need to do is actually the deployment. You need to make sure that you take your application and containerize it. Typically, it's a few steps, and it's not an advanced. It's not something advanced. And often, what you'll find out is that out there's over 1 million of images on Docker Hub and other places where they've already created basic images for most technologies. So most technologies out there are already supported and already containerized. In reality, all you need to do is say, use this image and take my application and bundle it with that image and create a new image from that, which I will be using, carrying on. That's the process. I see some more comments in the chat. Yeah, okay, that's from the story. Great. Another example here is, for those of you who are familiar with WebLogic and have been running WebLogic, you probably know that installing and running WebLogic, to some, that might be, it's not, let's say, the fastest process to install WebLogic. You have a few, there are a few parts in it. There's the concept of operators, which is written down here. The concept of operators is another concept in the cloud native world, or in Kubernetes, is that you can create this operator which can take an advanced application and manage it. So it becomes like almost like a natural part of Kubernetes, an integrated part of Kubernetes. Kubernetes will understand those different components inside WebLogic. So to give an example, a WebLogic domain. A WebLogic domain is something very specific to WebLogic. With an operator, you can start telling Kubernetes, create a new WebLogic domain for me, and it will do that. There's a one-time installation that you need to do when you create this, when you install this operator, but once you have that operator up and running, it can create new domains for you, it can delete domains, it can make sure that, again, like I said before, with making sure if something crashes, it will restart it, it'll take the health of it. So an operator can take care of all of that. To give another example of an operator, MySQL. If you're running MySQL database and you want to run a MySQL cluster, there's a MySQL operator which will allow you to spin up a full cluster. You can have a multi-master cluster or a master-slave or primary-secondary cluster, and the operator will spin that up for you. It will also take care of backups. It will also be able to create new MySQL instances from a backup. So it's almost like a PaaS service, right? But it's still, but you're 100% in control. You're managing the application. And this is the power of, I would say, both Kubernetes, but also operators, and like I said, Helm charts, the ecosystem of tools around Kubernetes. You get almost the same power as a cloud vendor, because you're able to create and automate so many things with so much ease. That's the main thing. So in this example, like I said, it's a WebLogic, again, a CI/CD build server. You push the Docker images to a registry. You pull WebLogic and the operator from the registry, run those on Kubernetes, and then you deploy your production images. And that will give you, your both the operator and the WebLogic domains. So what do we at Oracle, what do we have when it comes to cloud native? We have a bunch of services, and obviously I'm not going to deep dive into all of these today. I think the main point was just to highlight some of these benefits and what you can achieve. Container engine is a key component here. The registry is where you store your images. Develop a cloud service, or now called Visual Build a Cloud Service, is a CI/CD service where you can do your automation, run your deployments, basically have your scripts run from there, run your testing. So often testing is an important component of any deployment. So being able to spin up an environment, then run your functional testing, get the results, and if things are okay, then continue. That's all happening with Developer Cloud Service. Resource Manager, if you're looking to automate VMs or cloud resources. So you can, it's a service which can take Terraform scripts and execute them. You can run in plan mode to see how it will react, and you can apply them to actually execute the Terraform scripts. So it's basically, it allows you to have one place to manage everything around Terraform files. API Gateway. Once you have your services running, often you would need like a unified way to access those services, control things like requests coming in, how many requests, and etc. And that's all happening in the API Gateway. Functions is a serverless framework which we have as an open source solution, so you can run that locally or on a VM. But it also comes as a PaaS service. So and it's also built on the same concept of containers. You can take your function, you bundle it into a container, and then you push it, and it'll be executed on events and triggers. And then from a, let's say, management perspective, there's a bunch of services to both monitor, log, to notify you in case of issues. And there's events which basically can react on different events happening on the cloud environment. Let's say a new file is created in object storage. Well, trigger this function to convert that file. So today, I focused mainly on Kubernetes because that's the core component, and I think once you kind of that's the main, I think, the biggest chunk here. But reality is there's a lot of other services and ways of working which can also further enhance and further automate, an application. Streaming, often when you have, when you need message queues, etc., it's a managed service for like a queue service. So all in all, I'd say, cloud native, to conclude on this, cloud native is a set of technologies to build and run scalable applications in a modern dynamic environment, right? It enables you to, agility, use resources more efficiently, and develop portable apps without locking, right? So you keep the freedom to develop in whatever language you want, because you can containerize everything. As a system admin, you don't have to worry about the 50 languages that your developers have picked, because at the end of the day, you only have to focus on, the underlying system, which is the Kubernetes cluster, which is partially managed if it's in the cloud. So all you need to worry about is like, okay, am I getting, is the monitoring working? Am I, having transparency to see what's going on, the resources, security, etc. But whatever your teams are putting inside the containers is something that you don't need to worry about. So it removes some sort of you can say headache from your table. Of course, you want to make sure that whatever they have in the containers is secure as well, etc. And there are ways to check containers are minimal and they don't have any additional things installed, etc. So a few examples of customers that have done this. CERN has run two things. This is just a simple. The example here is just an app they ran for a registration app. But recently, they've also taken WebLogic and run that at Kubernetes, and they're spinning up Kubernetes WebLogic domains in minutes compared to like what they used to do. That's something they've been very, very happy about. There are other examples with other startups, and there are quite a lot of those. These guys here, they basically focus on fashion. What they've done is they use GPUs with Kubernetes. So they use, again, just to show the flexibility, you can use underlying GPUs to build your models, etc. And often in a case like that, you want to be able to scale up when you need to build your models quickly, and then just scale down when you don't need them because they're quite expensive. And this is what Snaptech has done here. With that, I want to hand over to you, Tori.
Hey, okay. Thank you, Hassan. I invite, if there are questions, to post into the Q&A. Just waiting, and in the meantime, if there are no questions, again, a spot on Developer Live Java coming in September 17. So I hope to see you the day. There are 8 sessions, panel, and also hands-on lab where you can actually try yourself with the Oracle Cloud platform. I also posted into the chat a bit link. If you want, you can ask for an Oracle Cloud free tier account, and almost all the stuff that Hassan mentioned during this presentation are there, and you can test it. So.
And maybe one thing to mention again, this was the session, we're running another session, Ettore, right, very soon, which will be way more technical. This was the soft version of it. The next one will be, some more examples, real examples on how to do things, so a more hands-on approach.
Exactly. So again, I don't see questions, Hassan.
Nope.
So if you want, you can also be engaged with us through the AskTOM platform on the office hour. We are there. And if you want, you can send us a message. I see a question. Sorry. it's just a big thank you for you.
Oh, fantastic. Thank you for joining.
Thank you so much, everybody. See you soon. Stay safe.